Hello, my AB/BC students. This is the 2017 AB and BC question number 4. This was the famous question everybody was talking about. The memes were flying with potatoes. So let's do this. It's very similar to the weight of the birds problem and to the landfill problem that we've done previously, but it's different. So they have similar problems, and if you just memorize steps and really don't know what you're doing, you're gonna kind of get thrown off. And I think that's why they did this, to make sure you understand the concepts. So at t equals 0, you have a boiled potato, and it's taken from a pot left to cool in the kitchen. So you can picture a potato sitting on the counter somewhere, and it's cooling off because it just came out of a boiling water. The internal temperature of the potato is 91 degrees at times t equals 0. So I'm going to write that down. And do we have something for the temperature of the potato? Yes. I believe H is the temperature of the potato. Let me double check. Yes. So H of 0, that's the temperature of the potato at 0, is going to be 91 degrees Celsius. So they tell us that. The internal temperature of the potato and the internal, okay, this is important. There's a reason they're telling you that. So H is greater than 27 always. And let's keep reading. The internal temperature of the potato at time t minutes can be, so this is the rate of change of the temperature. So the temperature is decreasing, and this is the rate at which it's decreasing. So we do not have the equation of the temperature of the potato. It's not given. But we want to estimate the temperature at 3. How do you get the temperature without knowing the equation? Well, all we can do is estimate, and that's what they're asking us to do. So equation of the line tangent. They could have used a linear approximation instead of saying equation line tangent. So we have to immediately do this. Y equals, no, not y equals. Y minus y1 equals mx minus x1. Now, y is your dependent variable, x is your independent variable. So in this problem, basically we have t and t1 really, and y is h and h1. But we'll leave it in our y form. And t1, they told us at times t equals 3. So t1, or actually x1, is 3. Now we need to know, no, that's what we're trying to estimate, sorry. I am getting ahead of myself. Let me make it prettier for y'all. So we know x1 is 0 because they told us the tangent line at 0. That's where the tangent line is touching the graph. So a quick visual off to the side. Here's the function. We want a tangent line at a specific point, and they're telling us t is 0 there. I don't know if that's what the graph looks like, but I'm just giving you a picture. So we know that we can find the green line. We don't know the blue line. So what is your y at that point? So here's a question. When t is 0, what is y or h? Look, I wrote that down right here, 91. So your h1, which is our y1, is 91. And the next step is, how do we find the slope of the tangent line? Well, golly gee willikers, hopefully by now you know it's dh dt, and we want that when t is 0. Okay, so we start plugging that information in. If you look here, there is no t. But when t is 0, we know h is 91. So we're going to get this. You could leave your answer just like that. You don't have to simplify. So I will explain. So now we have, this is part A, by the way. We have everything we need for our equation of our tangent line. And so if I solve for y, that's my equation, my tangent line. That's the first part. But then they want to use this to approximate the temperature at 3. So what it's actually asking for, so suppose that's T is 3. Since we don't have the equation of the blue line, we can find that point right there. If we can find the y value when T is 3 on this green line, that'll give us the y value, approximate y value of the blue line, because close by it kind of follows. That's the logic. So here's what I want to do. I want h of 3 is approximately equal to y of 3, which is negative 16 times 3 plus 90. Don't simplify. And in fact, you could have, instead of using this, you could have plugged that in. And so this would have been an appropriate answer also. Where you didn't simplify. That's probably the wisest answer right there. So that is the answer. It comes out to be 43 degrees. Did they ask for units? Let's read it again. It didn't ask for units, so I don't need the units. Uh-oh. Let's see. I think everything's good. 48. Uh-oh, I think my math is off here somewhere. Let me double check. Oh, it's 91. Like, where'd that 0 come from? Drugs, don't do drugs. There. All right, that is part A. We are done. That is such a familiar problem. You should be very comfortable with that. We've done a lot of tangent line approximations. So part B, we have to find the second derivative. First step. We have to use that. To use that, we have to find it. And we want to know if up here in the right corner, if that approximation is above or below. How do you know if it's above or below? So I'll show you where we're heading. If that were my approximation, hopefully you can see the approximation on the bottom one here, it's under, it's too small. Here it's too big. And what determines that? It's not increasing, decreasing, but it's the shape of this curve. If it's concave up, it's going to be over. Concave down, the approximation is over. Concave up, the approximation is under. So I need to determine if the second derivative is positive or negative. So that's my plan of attack. I need to find the second derivative first, but we already have the first derivative. And here is one of the weird parts about this. A lot of people would take the derivative and treat h as your variable, and it'd be negative 1/4, and that'd be your answer. But hopefully you're starting to get this. T is my variable. H, that's not T. If that were T, the answer would be negative 1/4. But that's not T. H here is my function. That is actually a function, not a variable. That is a function, so I box it because we've called it box all year long. So I want the derivative of box. So when we take the derivative of the left side, we get the second derivative. Negative 1/4 is a constant in front of a function. I just copy that constant. And what's the derivative of h? If h is a function, the derivative of h with respect to t is dh dt. The derivative of 27 is 0, negative 27, so that's gone. Now, I believe, now we just have to figure out what this is. So they want the second derivative when t is 3. So you might say, well, how do I plug in 3 here? What you could do is plug in 3 into the dHdt, get that value, then plug it in here. Or you can replace dHdt with all of that. So let me do this. That part here is negative 1/4, right? And then I'm going to take my dHdt and plug it in here. So there's another negative 1/4. My h is ooh, no, whoa, this double whammy. The h isn't 3. When t is 3, what is h? We determined that was 91 earlier. So that's the answer. Well, first, that's not the answer. That's the second derivative. Oh, let me back up. I just messed up totally. We don't want the derivative at that point. So just because I know it's concave down here, doesn't mean it's concave down here. It could squirt up. So we want the general derivative. So I kind of messed up. We need to back up. I was getting ahead of myself. So they want the second derivative only, not at a specific point. And I don't want to start this video over, so that's why I am just continuing on. So it's negative 1/4, and then I place that in there. Now we're cooking. So this is 1/16 h minus 27. And the question is this positive or negative? And you might think, well, it depends on what h is. But if you would have annotated earlier, you probably would have remembered that we stated h is always greater than 27. So now we can say, since h is greater than 27, therefore the second derivative of h with respect to t is positive. Okay, if it's positive, that means we're concave up. Therefore, we have an underestimate. The answer in part A is an underestimate. Bam. Done with part B. Let's go to part C. Okay, for t less than 10, an alternate model for the temperature is G. So the first one was a model of how temperature of potatoes decrease over time, but someone else comes up with a new model. This is their model. And the starting temperature is the same. Find an expression for G of t based on this model. What is the internal temperature at 3? So we want G of t. We want to solve for G. We have dg dt. How do we solve for G? Well, normally we integrate, so that's the process we're going to take. So we have dg dt. And we usually just integrate both sides, but I'm going to show you the problem, and hopefully you start to understand where the problem lies. If I try to integrate both sides, here's what happens. T is my variable. That's not t. That's a problem. I can't just do my normal antiderivative stuff. I realize this g here is actually my function. Whenever that happens, where your function is what you're trying to integrate, not your variable, you're going to have to separate variables. So what should happen is you have to rewrite this. I'm going to divide both sides by that, but not the negative, because the negative complicates things. It doesn't matter where that negative is. I'm only going to bring the g minus 27 to the 2/3. And I'm going to leave the negative on the right side. Now we integrate both sides. Now again, you could have brought the negative to the left side, but that would have been a pain in the buttocks. You would have had just a little extra work that's not necessary. So let's continue. The left side, I have a u substitution situation where u is g minus 27, du is dg. Ah, that's not bad at all. The right side, there's a 1 there, even though you don't see it. The antiderivative of negative 1 is negative 1t. And don't forget your plus c. The left side, here is what's going to happen. All of this becomes u. And this dg here becomes du. Oh, it's 1 over that. Okay, back up. Beep, beep, beep. It's 1 over that. Sorry, Charlie. It's 1 over u to the 2/3. So I have, here lies my next problem. I don't like that, but you should see the rewrite of this. So let me bring everything up here. The antiderivative of u to the negative 2 is I add 1 to the exponent, and I divide by that. Woo! Woo! I shouldn't have that. And then I end up with this. So I want to solve for g. Well, g, I better plug g back in. So this goes in for u. So I want to solve for g and c. I have a problem with c over here. What is c? So you'll get a point for finding c by plugging in your initial condition that was given here. G of 0 is 91. So side work, whoa, side work. Where am I going to do it? I'm going to do it down here. They told us G of 0 is 91. So I'm going to plug into the equation we just found 0 and 91. 3 times 91 minus 27 to the 1/3 equals 0 plus c. Hey, I found my c. My c is that weird thing. All right, we will continue. Now you can simplify that. The 91 minus 27 to 1/3 times 3, or not. So in this case, I am not going to show you, to model what you should do. There. Now I'm going to try to solve for g. Well, let's get rid of the 3 by dividing both sides by 3. Those will cancel. I get g minus 27 to the 1/3 equals minus t over 3. The 3's will cancel on the next one. 91 minus 27 to the 1/3. Yeah. So we're good so far. Now, I need to get rid of the 1/3 because I'm trying to solve for g. That gets in the way. So I'm going to cube both sides. So g, ooh, G. G minus 27 is this all cubed, and then I add 27 to both sides. And that answer would be fine. For G. Now, a couple of side notes. Well, I'm not going to add a side note. You could, if you wanted to, simplify that. 91 minus 27 is 64. Cube root of 64 is 4. So you could simplify that down to 4, but I'm going to model wise behavior. So they want now to approximate the temperature when T is 3. So the first one we did a linear approximation. This is going to be, well, actually we're not. According to this model, this will be the actual temperature. So I'm going to plug in 3 for T. G of 3, because that's what they're asking for. That'll be negative 3 over 3 plus 91 minus 27 to the 1/3 cubed plus 27. That's it. That's all you got to do. We're done. Let me see if my answer comes out right. Yeah. Okay, stop here. Stop here. I'm just going to make sure my answer matches what the... So you shouldn't do this. Negative 1 plus 4 cubed plus 27. That's going to be 27 plus 27. That's 54. Yes, it matches the book's answer. So that's it for number 4. Off to the next problem. I think we're skipping 5 and we're going to go to 6. I think. I hope. Yes, we're jumping to number 6. See ya at number 6.